Hi, and welcome to Allen High School's discussion of chemistry. Electroplating is where we're heading next. Now, in order to do these electroplating, we need to just remember a few key things, actually. The first is that plating happens at the cathode. Remember that copper ion would be reduced to copper metal at the cathode. So plating always occurs at the cathode. Remember, the cathode is the one that increases in mass. Now, I like to do these calculations by using dimensional analysis. There are some formulas you could plug into if you want. I don't know those offhand, but I'm sure we could find those. For now, I want to do it by dimensional analysis. And in order to do that, we need to remember two things. The first is that an amp, 1 amp, is the same thing as 1 coulomb per second. So if I have 2.40 amps, that means 2.40 coulombs of charge will pass through every 1 second. So that's a unit conversion and equality there that we can use. Now, the second important thing that you have to remember or know both, is Faraday's constant. That's our bridge between the world of chemistry, which is going to be mass, and the world of electricity in amps. So that Faraday's constant tells us we'll have 96,000 coulombs for every 1 mole of electrons that are transferred. Now, armed with those two pieces of knowledge, the rest is prior knowledge. Okay, so I'm going to set this up. I've worked this so I know how many steps I need. So I think that's it. Okay, so I'm going to start with my given, and that's 30 minutes. All right, so you're typically going to be going from time to mass or mass back to time. Now, you may be missing a component in between, and I usually just leave that as my x rather than do formulas, and we'll see that on an AP question. So I have 30 minutes, but my link is via seconds, so I have to get that to seconds. For every 1 minute, there's 60 seconds, so my minutes cancel. Now I can use my amp as a conversion factor because this tells me that I'm going to have 2.4 coulombs of charge for every 1 second. So that is new. Okay. Now, Faraday's constant tells me that for every 96,500 coulombs, I have 1 mole of electrons involved. 1 mole of electrons. That also is somewhat new. I'm almost there. I'm now going from my world of electricity into my world of mass and elements. Now, copper requires 2 electrons. So I need 2 moles of electrons for every 1 copper that I'm going to plate. 1 mole of copper. And mass to moles, use molar mass, and we're there. 63.55 grams for every 1 mole of copper. And assuming I did my algebra correct, and you will tell me if I didn't, I can count on that, I get 1.42 grams of copper plated. Now, sometimes they'll give you this, a question would give you this and say, ask for something inside. I still just set it up and leave that as my x and then follow through with my algebra. Okay, let's do the other direction. This time I want to know time, and I'm given mass. And I have silver ion plating, so that requires 1 mole of electrons for the silver plating to occur. Now, instead of amps, I'm going to write that as 0.800 coulombs for every 1 second. That's what an amp means. Set up my dimensional analysis. Okay, and my given is 2.5 grams. So I've got 2.50 grams of silver. We relate substances on the mole level, not on the mass level. So we need to eliminate grams, mass to moles, use molar mass. So that's per 1 mole of silver. Now I need to get into the world of electricity. So I want to get rid of moles of silver and go to moles of electrons. And that happens to be 1 to 1. Now I'm very near my world of electricity. Coulombs, Faraday's constant, remember, tells us that for every 1 mole of electrons, I have 96,500 coulombs of charge. Now I can use my amp, and an amp tells me that I have 0.800 coulombs for every 1 second. And I got 2.80 times 10 to the 3rd seconds. What that means is that if I want to plate out 2.5 grams of silver and I set my power supply to that many amps, I would have to run my cell for that many seconds in order to get 2.50 grams of silver to plate out. Okay, we're going to look at a couple of other key parts of electrolysis before we move on to AP questions. So until then, this is signing off.